If you guys have seen any of the webinars I've done recently, I've been talking about AI and I've gotten a ton of questions on it and a ton of questions from our customers that they really want a deeper dive. So we're going to do a little bit more with that to really figure out exactly what is AI itself, because you see that term attached to absolutely everything. Everything's powered by AI, right? So what does that actually mean? I think it's really important that we get into that. So just a quick agenda here. Before I get too far into it, I do want to introduce Trellix, the company I work for, and then we'll go into the understanding of different types, and then the use cases for them, and then we'll do a review of some of the dangers of them. So quick intro for those of you who haven't seen a webinar with me already. I'm Martin Holsey. I'm CTO for Cloud and AI here at Trellix. I have a long history in security, starting with incident response and running a security operations center, and then got into big data analytics, and all that's why I'll be speaking on here in just a minute, and all the fun that we got into over the last decade of doing machine learning and things like that. And then I got into cloud and cloud architecture, and most recently I've gotten into AI. So that's kind of been the arc of my focus on emerging technologies. So for those of you who are not familiar with Trellix, and I run into many people who are not sure who we are the combination of McAfee Enterprise and FireEye. And generally speaking, most people know about those two companies. So if you know about those two companies, now you know about where Trellix came from. You probably don't know us as a company, though. We've done a lot since the merger, and we now call ourselves a living security, and I think you'll see why. All right, so this is what I really want to cover today. What are the different types of AI? When we hear AI, what do we talk about? All right, so this is the really focus on the data component, as that is today's theme is data. So let's talk about what this actually means. So you probably heard the term AI machine learning for a very long time. As I said, we started doing this about a decade ago, then at Mandiant and later FireEye and now Trellix. But really what we're talking about is putting a ton of data into one place and getting some meaningful information out of it in a way that doesn't look just like a query. So we're used to having a lot of data in one place, and you can, ask it questions and say, I'm going to do a select SQL statement or something like that and get a bunch of data out of it. That's obviously not what machine learning is. Machine learning is going the other way around. It's essentially putting in the question you're going to ask and then running all the data through that question to find out, what the answer is or what doesn't look like the answer. So a very simple example here. Given this data stream, we'll just dumb it down to, what we call it a single vector or single dimension, is in, look at this sequence of numbers. 1, 2, 1, 1, et cetera. And then when you get to the end, you say, okay, what about 10? Is that normal? Well, obviously not. Anybody can see that 10 is very abnormal when you've had a bunch of 1s and 2s, right? So this is one of the core parts of machine learning, is to say, if we stick a petabyte of 1s and 2s through this thing, and then we ask it, is 10 normal? It's going to say no. So that's one of the biggest things that it does. The second thing that it does really importantly is what comes next. So if you gave it all those 1s and 2s and you say, what do you think is going to happen next? It's going to say, well, probably 1 or 2, and give you that. And actually, this is where you're going to see some overlap as we get into the generative AI stuff next. That is sort of a version of this. All right, so what are some of the basic use cases for machine learning? Again, these are probably the ones that you've heard of, and that's important because that's the touchstone for understanding the old AI and the new AI is one way to think of it. So anomaly detection, that's what we just showed. The 10 is a spike or an aberration. But actually, you can use this for a lot of image recognition as well. So if you put 100 pictures through and you say all these are cat, then any other picture that comes through that looks sort of kind of like that will have that label of cat. And so just like we saw with that series of 1s and 2s, it may be a much more complicated stream of bytes, but it's still a bunch of numbers. Pictures are made up of numbers, and you can track those through and then ask that same kind of question, or notice when something is not a cat after a bunch of cats in a row, so to speak. Then that's where the predictive part comes in. So if we say, well, based on, for instance, with stock predictions, I might see, if you ever watch the show Billions, they call this quant. But basically looking at day trading style of stock numbers that come through on a microsecond basis, you can find patterns in there essentially using some things like machine learning. All right. So what are the SWOT analysis here? Strengths, weaknesses, opportunities, and threats. So the strengths, and these have been this way for years and continue to be so. There's still a lot of great use cases for it. So the strengths on machine learning are that it's knowable, as in these been established for a long time. There's a broad range, and it's quite robust, as in you generally know why you're getting an answer when you get an answer, and that becomes important in the next section. On the weaknesses side, this does require a ton of data, and it's got to be labeled correctly. This is the hardest thing to do with machine learning, is getting that quality data. So at Trellix, we have an entire product, our XDR, that focuses at the first part of its mission to normalize data and put it into something that makes sense. The machine learning is absolutely worthless if you don't have labeled good data. And what I have found in my experience of the many years working on this is that is actually 90% of the effort. The fun, easy part is doing the science at the end, where you get to do the anomaly detection and all of that. But the real hard work is getting quality data put in there, in a way that makes sense. If you saw some of my previous webinars, I talked about the Amazon Security Lake, and that is another way to do that, where you can get data in a guaranteed format. And there's other data lakes out there that will help. But the idea is that you can't do any machine learning if you don't have quality data. On the opportunity side, this is some emerging research that we see here, along with some already existing research on being able to combine models. So it takes a lot of effort, as we said, to train these models on the quality data. You can take the output from that training and combine that with other models to get something even better. So you can see a little handshake there for the robots. There's also expansion into other industries, and collaborating with some of the other AI that we'll talk about later. So it's certainly a good building block onto other things. And then the threats here, output quality. So you can get, things that are statistically or, technically spikes or, out of the ordinary, but not helpful at all. There's also the ability, just when you're collecting that much data, to have problems with that much data in the first place. So the fact that you have to collect that data comes with a lot of strings attached. You have to, secure it, you have to store it, you have to do all those things. And then there are some other things that are just part of automation, which is they tend to over rely on that instead of human expertise. And you can look at some of the anomaly detections that you get out of there and not interpret them correctly. All right, so moving on to generative AI. Hopefully you guys have seen this before. I'm going to talk a little bit more about this in depth, because now that you saw what the machine learning does, you can understand a little bit more what these boxes do here. So you saw those boxes of 1s and 2s earlier and saying, well, this generally looks like this. So imagine that those boxes of 1s and 2s in the data stream were set up in more like a grid or a multi-dimensional grid, so like a cube. And then you're trying to predict the streams and how those things are attached. That's not a perfect technical way to explain it, but that's along the right lines of kind of how to think about how generative AI works. It's based on some of the same things that you get in traditional machine learning, but just scaled out to many, many dimensions. It becomes much more complicated. And again, that's not the perfect explanation, but I think it's a good way to think of it and a good way to understand the costs involved with it that we'll dive into in just a little bit here around what it takes to actually do that. Because you're setting up not just a relationship that's single threaded like that with one, it's many, many, many. And so we're talking billions of those relationships. And so that's what all these boxes get tied together. And you see that each box has a bunch of little boxes inside of there with the lines, and that's the level of complexity that we're talking about, is several orders of magnitude more complicated. So how do we run Gen AI? There's a lot of different ways to do this. We'll go to the 3 sort of headline methods. So one is a public service. This is probably the one you're most familiar with, ChatGPT or an OpenAI API. There's a number of other ways to do it. Hugging Face has their own API. And that's a service that's multi-tenant. So you have, everybody's hitting the same API, and that comes with some pros and cons. On the good side, it's very easy to use. You can, for $20 a month, you can get ChatGPT Plus. You can get it for free if you want the non-plus version. So that's cool. But the first thing that ChatGPT will say when you sign up is don't send it any sensitive data. So that's generally not a good place to put your sensitive data. The second way to run it is a little bit still SaaS, but it's more single tenant. And so this looks like Amazon Bedrock, Google Vertex AI, or the OpenAI implementation on Microsoft. And so these are single tenant editions of what's happening here. And that's technically, it's a little hard to explain single tenant versus multi-tenant in some of these SaaS services. But that is essentially the guarantee that you get with these services, that they're not going to share your data. So it is safer to put your data there than the public service itself, because there are more assurances that go with it. This is worth an entire hour discussion right there. I won't go into all of it, but I'm just trying to give you sort of an idea of the full gamut of all the options out there. And then lastly, running your own. And again, you could do, multi-day workshops on this. But essentially, there's two options for running your own. You can either do a cloud vendor or bare metal. And if you do cloud vendor, even under there, you can run it just as a virtual machine on a cloud vendor, or you can use an assisted framework, something like AWS SageMaker, where you can take a model and they basically handle all the heavy lifting, but it's running using their framework, so that you don't have to figure that out. But it's still a virtual machine essentially running in your cloud tenant. So it's basically running it yourself. And then lastly, of course, if you can run it on-prem or anywhere you want, all of that is possible, but as you might imagine, takes a lot more work. So I want to talk a little bit about fine-tuning. This is one of the key things that I think you need to understand about the difference between machine learning and generative AI. Far and away, the biggest thing that I hear about generative AI is, we need to train it. The vast majority of the time, you do not, in fact, need to train a model for generative AI. Most of them, because they're general models, do just fine without any training whatsoever. They are pre-trained, as they say. And you can generally use a pre-trained model to answer your questions as long as you give it the right data in the prompt. And so that's why we'll look at some prompt engineering here in just a second. So there are some reasons why you might want to do fine tuning. This is what I would call a very advanced level of generative AI, because you basically want to kind of figure out the basics first and prove to yourself that you really need to get to that optimization where you're doing the fine tuning. There are a few cases where it is super required. If you have really specific technical documents that need to go in there, and they don't fit in a context window, and we'll talk about what that is in just a little bit, as in, you can't stick it in a prompt and ask the question, then you probably will need to do some fine tuning for that. But 9 times out of 10, fine tuning is probably not the answer. And so that's one of the big takeaways I want you to have from today's session. So there are some good reasons to do it in this specialized knowledge. If you have those domain specific things, maybe even though the generative AI models know a lot about things like chemistry, they may not know, specific formulas that your company has developed or trade secrets. Those kinds of things would be good for doing fine tuning and adding in. As you get further down the road and you start to look at cost optimization, you'll find that reducing your prompt sizes directly impacts the costs in a good way. So if you do fine tuning to the point where you don't have to include those things in your prompt, that can lower the cost of actually running your LLM in production. So that's another good reason to do it. But again, these are more advanced. And so it's not the place you generally want to start. And so when you do these, it costs a good bit of money to do the training, not nearly as much as it costs to do the pre-training. So when you use something like a ChatGPT that costs millions of dollars to train, it's not going to be like that, but it may be thousands of dollars to do the training, depending on how much data you want to train. So it generally is considerable and something that you need to account for and budget for. In building that perfect data set, you heard me talk earlier about how machine learning required perfect data. You do need perfect data to do that fine tuning or something very close to perfect. All right, this is a good one. I want to really dive into prompt engineering here on this slide, because I'm not going to go, again, you could do entire month-long workshops on prompt engineering, and there's tons of stuff out there you can read about. I just kind of wanted to whet your appetite a little bit for it's something that really opened my eyes a while back on just how new this technology is compared to everything else that we've ever done in computers, honestly. So not all LLMs are created equally, as in they all, have different strengths and weaknesses, and not all prompts are either. So this paper that I'm referring to here proved out, and I've seen firsthand practical examples of this being true. So I can, with my own eyes, I've seen a prompt not work if you don't include this thing, and it work when you do include it. And what is mind blowing to me is that you invoke emotion and you get a different response from these things. And I still struggle with this because it's just so different than we've ever seen before. But this example they have here that I point out, take a deep breath. So you could have a prompt that says, write me some code that does something and put it into ChatGPT or wherever. You can then add on to that, take a deep breath and think step by step, and it will come up with a better answer. And this is a great way to show that this is something we've not dealt with before, honestly, as a society. Trying to figure out that there is these sort of Harry Potter like magic words that you can use like you're some kind of wizard, and they actually have a big performance improvement on what you're going to get out, to the point where a few weeks ago I was trying to get something to work. I was getting nothing useful out, and I added take a deep breath in front of it, and suddenly it produced usable information, and that really sold it for me. I had to dive into these papers and get a better understanding of what's going on. And the high level why this works is that it's been trained on basically the internet. Is the pre-training, and that's a lot of human emotion in there, and so that's kind of how this happens. But that said, if you look at this paper, there's still a lot people are trying to figure out on exactly why it manifests exactly like this. But I just wanted to raise this so that that there's an entire new field opening up on prompt engineering to figure out how these things work, and they have dramatic effects. So this is definitely something that we haven't seen before, and something I really want to focus on today. And so maybe you saw this one in a previous webinar I did. I just want to circle back to this. So LLMs can read data in almost any format and make these decisions. So now that you kind of think of, well, there's almost emotion attached to these things, you understand that they're doing a lot of thinking under the hood there. And so they can understand CSVs, and they can understand the concept of something being malicious. And so when you ask, read in all this security data and tell me what happened and if anything was malicious, it's able to do that, which is really incredible. And then the other thing I want to point out here is that with machine learning, everything would have to be labeled perfectly, but LLMs are really, really good at kind of doing fuzzy matching, as in they'll say, it's AWS _ CloudTrail. Well, that's still CloudTrail. They know what AWS is, and the LLM knows what CloudTrail is. And so just because there's an underscore there, it doesn't mess it up. It knows what Office 365 is. And so it can, figure that out without you having to tell it, oh, if there's an underscore in there, don't worry about it. With machine learning, those are two completely different things. If you have, CloudTrail and then AWS _ CloudTrail, those will show up with, different statistics, et cetera. So what do we use these for? You can see the, image and video creation, email creation, software creation, all those different things. But today I want to talk just real quickly about what can't we do with Gen AI. So I just talked about how great it is, right? Well, we can't send a lot of data to it because it's too slow. We can't ask a lot of questions because it's too expensive. So think about that compared to the machine learning. Machine learning is built to send a lot of data into. You don't send a lot of data into Gen AI. That's a big difference. We can't always trust its answers. Gen AI will hallucinate regularly, and that's very difficult. You have to really watch out for that, and you have to have ways to safeguard against that. We can't always get quick answers. It may take minutes, and we can't understand why it gives the answers that it gives. So with machine learning, you can generally look at the model and say, oh, okay, well, the statistics said this, and that's why it said this was an aberration. You can't really go back and figure out why you got an answer out of an LLM. And that is also something that's totally new to our industry. All right, so what's the SWOT analysis here? You can understand and create as a strength, create new things. It can be somewhat creative, not quite like a human, but gets there. Understands raw text like a human. As I just pointed out, fuzzy matching is a big deal here. And it's really great for automating anything with content heavy sectors, especially anytime you have really boring stuff that you're trying to do. So that's why I use this robot motif throughout all of this. This is trying to automate this stuff out. The weaknesses, so the mistakes that we talked about with hallucinations and the cost. This gets to be very expensive. You can't ask a ton of questions without really running up your bill as it stands right now. Maybe there'll be advances in the next few years that drop that cost, but right now it's considerable. And the opportunities and the threats are both almost unlimited. And this gets to be pretty interesting. So on the opportunity side, you have, next gen entertainment, synthetic data generation, personalized content, all that stuff. It goes on and on. It's almost unlimited. But also there are problems, circumvention of digital protections. And we'll show you an example of that just a little bit here. Deep fakes, you guys have seen that a ton. This is going to cause real problems because it's very difficult to figure out what's real and what isn't, and that is a significant problem. And then the ethical concerns around content ownership. Supreme Court has weighed in. So far, content that's generated by AI is not owned by anyone unless you modify it slightly. All right, and then I've redone my LLM top 10 vulnerabilities for LLMs with a more rogues gallery approach here. This is a good way to think of it. I won't go through all of them. I did that in a previous webinar, but I do want to highlight now with this new context a few things. So the prompt injection, if you have an app that's receiving chats and things like that, you don't want to allow direct access because people can get into the template that you used for it. The insecure output handling, so making sure that you're not allowing sensitive information to be produced by the LLM as a response. And this is particularly important for something called retrieval augmentation generation, where you're using the LLM to receive a question. It might go out to a resource like email, grab something, put it back in the answer. Well, if the person who made the query wasn't supposed to get answers out of email, then that's a problem. So you need to be aware of that. And then the other one I want to mention is that sensitive information disclosure, making sure that it doesn't have access to things that it shouldn't. The real world attacks, there's a number of them. Running out of time here, so we'll go through each one of these. But basically all the vulnerabilities that I just talked about have examples in the real world where something bad has happened from them, along with coordinated attacks, et cetera. And at Trellix, we basically put all of these things into our detection factory here and get our unicorns and rainbows of magic out of it. And what that looks like specifically for securing generative AI is the ability to look at both the prompts and the responses that come out of things like Bedrock via something like CloudWatch. And then you can start to understand what's happening, first of all, get that observability, but also have rules and things to alert you when something does not look the way it should. And this is a really key thing. We do all this through our investigative steps, which start to automate a lot of the things that you would look at for that scenario, which makes it very powerful, and you can get through it. All right, so to sum up here, key takeaways. So there are two main types of AI. It's the machine learning and the generative AI. Generative AI is very powerful, and there's a lot of new opportunities, but it has a lot of considerations both on costs and protection. All right, with that, I look forward to your questions.